Hello my dear students. So we are going to solve this question from our equilibrium chapter. So before solving this question, I will give you information about my classes which I take both online and offline class. So here you can opt, if you are interested, you can opt for either online class or offline class as per your convenience, and the fees for our offline class is actually more, but for the online class it is even 1/10 of that of the offline class. So you can join whichever is suitable for you. And here I have given my email id. So my email id here, you can just drop me a mail. This is my email id, class@mumbaiedutech.in. So here you can drop your mail if you are interested in my joining my class. So I am taking for MYP 4, MYP 5 and IBDP, IBDP both 11th and 12th. So and even I take for IGCSE 9th and 10th, and then A levels also I take. So in this way you can if you are interested, you can drop me a mail, so I will give you further information. So let's solve the question now. So here the question says that the equation for one reversible reaction involving oxides of nitrogen is shown here. So N2O4 is forming NO2. So now here delta H value they have given as plus 58 kilojoules. So let's solve this question. So they have asked here, write an expression for the equilibrium constant for the reaction, explain the significance of horizontal part of the line. So first we will write the equilibrium constant expression. So this we will write here Kc value. So Kc value, as I have explained in my previous videos also, you have to write the product. Here product form is NO2. So NO2 you will write in the numerator side and write in a square bracket, and this before you can see 2 is written here. So this 2 will become indice of this, it will come on the top. Now here upon, so here this reactant you have to write. So reactant is N2O4. So reactant also you have to write in the denominator, but you have to write in a square bracket. Reactant also you have to write in a square bracket. So N2O4 in a square bracket, and before N2O4 nothing is written, that means 1. So 1 is written means here we can write here 1 as indice, but 1 is generally not represented, not written here. So this is the our equilibrium constant expression Kc for this reaction. Now here they have asked the further part, explain the significance of the horizontal part of the line on the graph. So I will explain you this. As you can see here, this yellow line, so this is for our here reactant. So initially reactants were high, that reactant was high, it was 0.8. So it got reduced and it came here at around nearly at 0.4. So here you can see it came here, and then it became equilibrium, it came to this equilibrium position, okay, at this point. So now here you can see, now we will talk about our product. So product with the green I will explain you. So product was there. So product initially was 0 because reactant has just started reacting, so no product was formed. Then after the reaction the product form gradually increased from 0.2 to 0.4. Then after 0.4 it became parallel. Now after 0.4 it is reaching over 0.6. At the 0.4 you can see at this point both the graphs are cutting each other. So that means at this point now equilibrium has reached here. So that means equilibrium rate of forward reaction and rate of backward reaction is same here. This at this point, this is the particular point where it has become at 0.4. So here then after sometimes you can see the graph is becoming parallel. This graph, product graph and reactant graph, is becoming parallel to the x-axis. That means now here we can say that neither product is breaking to form reactant, nor reactant is combining to form the product. So when it becomes parallel, so this you should remember. Now the main thing what they have asked here, further question, state what can be deduced about the magnitude of Kc. So for this I will explain you. We will put the values of the here in this equation. So in this equation we will put the values. So let's put the value here, NO2. So NO2 is our, so NO2 has reached here, this, because NO2 is the product. So product has reached here, this. When it becomes parallel now, then you have to actually take a line and see where it is meeting on the our y-axis. So it is meeting around at 0.8. So that means the concentration of this concentration of product is 0.8. That means the concentration of NO2 is 0.8. So here we will substitute the values 0.8 for NO2 and whole square, because here 2 indices is there. So this, now here we have to do even for our reactant. So reactant I will draw with green colored line. So now reactant, it was 0.8, but after sometimes you can see it got reduced and became parallel. So here at where it is becoming parallel, we will take the line. It is becoming parallel means here at 0.4. So 0.4 we will write in the denominator for N2O4 in a square bracket. So we will solve this. 8 is the 64. So here 0.64, 0.64, okay, and upon 0.4. So here let's solve this. So the value will come to 1.6. So Kc value is coming to 1.6. We can write magnitude of our Kc value is 1.6, okay, or it will be greater than 1. We can guess also, because it is our what they are saying that here, okay. So we can guess also just by looking at the values, like numerator will have the higher value and denominator will have the lower value. So Kc value will be more than 1. So in this way we can guess also. So but it's better to solve like how I have shown here. Solve the next part of the question here. So the next part of the question is this: use the Le-Chatelier principle to predict the and explain the effect of increasing pressure on the position of equilibrium. So pressure, okay, and temperature also is very much. First I will explain you about the pressure. For pressure now you have to count the molecules. You should actually count. The main thing is that you should remember that you have to count the molecules on the reactant side and on the product side. As you can see here, on the product side the molecules here is actually 2, so 2 on the product side, and on the reactant side you can see only 1, because nothing is written before N2O4, so that means 1. So 1. So our always remember, increasing the pressure always actually what it does, it favors the side with the least molecule. So if you are increasing the pressure, so least molecule is here only one molecule N2O4. So the equilibrium will shift towards this side, left side, that is our reactant side. So increasing the pressure will actually shift the equilibrium to the left side. Now let's solve the next part. So next part is what actually they have asked the pressure and temperature also. Now we will talk about temperature. What happens if the temperature is increased? So instead of pressure now we will write here temperature. Okay, temperature. So what happens effect of increasing the temperature? So I will explain you this. Now here always remember, you have to, for whenever this type of question is asked for increasing temperature, you have to see whether it is endothermic reaction or exothermic reaction. So you can see here it is written here plus 58. Whenever plus value is given, that means it is our endothermic reaction. So it needs heat. It needs heat. Okay, so that means this reaction needs heat and you need to supply heat. So you are supplying heat and it needs heat. So that means you are supplying heat here. So what will happen here? The product form will be more. So that's why increasing the temperature will shift the equilibrium towards the our product side, that is towards the right side. So if you are increasing the temperature, the this will move towards our right side. Okay, so in this way the equilibrium will shift towards the right side. So that you have to see. And suppose here it is endothermic, but if suppose this value is given as minus instead of plus, some minus value is given, then what will happen? Because if it, that means if minus delta H value is minus, that means it is already having the heat is there already in the system and you are supplying more heat. Then what happens? The product, whatever product form will be there, that will break to form reactant. So the equilibrium will shift towards the left side for exothermic reaction, and for endothermic reaction what happens? It needs heat, so you are supplying heat, so it will shift towards the right side. State and explain the effect of catalyst on the forward and reverse reaction on the position of equilibrium and on the value of Kc. So for this now we have to refer our previous chapter, the previous chapter, that is kinetics. So let's refer that. So I will draw here Maxwell-Boltzmann curve for this one. On the x-axis it is actually fraction of particle with kinetic energy. So here this is x-axis, and y-axis is our having particle which is having kinetic energy. So always remember, our here the graph will look like this here. So graph will be like this here, somewhat it will be like this, but it will never touch our x-axis. So here you can see here, initially here you can see the EA, our activation energy was here. Activation energy was here, but when you put catalyst, so here you can see here actually so less molecules were there. You can see here so less molecule which were having. Here you can see the particle, this kinetic energy. So here you can see the particles which are after EA is having what here, they will have more kinetic energy. So more the kinetic energy means the kinetic energy will be greater than the activation energy. So whenever this will be there, that means the here chances this side the reaction will be very high. But what if you what happens if you add catalyst? So this EA is then EA shift towards this side, so more of the molecules will be covered in this area. Now EA shifts towards our left side. So here you can see now this many more molecules have come up. So it was stay here this area, these molecules were having that our kinetic energy more than activation energy. Now here more molecules have come here. So this catalyst is actually helping to increase the rate of the reaction. Okay, it is helping to increase the rate of the reaction by providing that it helps in actually increasing the kinetic energy, overcome the in order to overcome the activation energy. So it actually provides more energy, so more kinetic energy will be there. So whenever kinetic energy will be more means the particles, the molecules will move faster. Whenever it is moving faster, that means the chances of collision is more. Like on the highway the cars are running at a very high speed than on the normal road, so the chances of collision you will find on the highway is more. So in the same way here, more with the more kinetic energy, more collision will be there, and so more product will be formed here. And more for always remember, it just actually reduces the activation energy. Catalyst reduces the just the activation energy by increasing the now more the molecules will have kinetic energy, so the chances of collision will be more. But for both the reactant and the product, so for equilibrium reaction, even reactant will also have that much magnitude, that much quantity of that much quantity. Even product will have that much quantity of kinetic energy, and reactant will also have that much same quantity. So rate means the equilibrium will neither shift towards the right side nor towards the left side, because it will have the same magnitude of that kinetic energy. So for the reactant also and for the product also, so that's why it will not have any effect on the equilibrium. Okay, it will not neither shift the equilibrium to the left side nor to the right side. Thanks for watching my video. You can go through my email ID. You can drop an email if you want online or offline class. So let's see in the next video. Bye. Take